Yeah. Okay. So they get this project and they want to use Nemo Puppet on that project. And so, but they are an outsourcing company, so
Hmm.
they are forbidden to upload anything without permission from the clients. So they take Nemo Puppet to their clients to ask, okay, this product is cool. Can we use it in our project? And like maybe a week later, and you join the Discord group. So I thought like someone asked you to investigate on the Nemo Puppet. I thought that was the case.
Yeah, yeah. I don't know how I ended up on their Discord, to be honest. I may have seen some news and I thought the same, like, oh, this is very interesting. I want to know more. And
Yeah,
yeah,
by that time we start to post videos on the YouTube, but with
yeah,
zero,
maybe it was that. Yeah, and okay, so let's rewind a few years back. So can Ivan, can you talk a little bit about how you ended up doing what you do? Like, do you start it it's as like going to work in animation? I guess your background is more engineering, or how
yeah. When I was graduated as a computer science degree, so I study. I'm not an artist. I'm not an animator. Yeah. So when I'm in a, that's a bit long story. When I was in school, I developed a game. So after that game, I'm curious about how these amazing assets, videos, pictures, models,
Mhm.
animations are produced. I know every line of codes, but I don't know how about these assets. So I decided to take an intern at at an animation studio. Yeah, and that goes very well. And the Sean is the mocap leader. He used to be the mocap leader of the Weta Digital.
Oh,
He joined this Chinese company at that time, the Original Force. So
ah, I know.
yeah, I was just an intern. She is my boss. So I feel that this is really cool. I refused all the offers from the game companies and I joined the animation industry. So that was the beginning. Yeah.
Nice. So you
And
choose animation over games.
yeah.
I'm still in the middle.
But still, I have worked for several game companies like
Mm.
the Tencent and MiHoYo. Yeah.
Yeah, that's great. So you started on this on Original Force. I know Original Force. It's
Yeah.
one of the biggest. I would say I don't know if it's only outsourcing, but I think it's one of the biggest
Oh,
companies.
yeah, they produce films. They produce original films.
Yeah,
Yeah, but
that's
not too many. Yeah, and the TV series they produce a lot of things, including the original ones. But the original ones is a small part.
nice. Yeah, I think I met or I saw this last year on the Tokyo Game Show here. They always have a booth
Yeah, they are
to
huge.
show his
They are
works.
like 2,000 employees.
Wow, that's that's huge.
Yeah, it's huge.
Let's talk a little bit about Nemo Puppet because maybe
Yeah.
for the people that are listening the podcast, they don't know what we are talking about. So
Yeah.
what is Nemo Puppet and what it can do this technology?
Yes, New Puppet is an animation acceleration and technology. I would say it makes the rig run faster automatically with not any effort from the riggers or animators. And it's okay if it's okay. I share the screen now.
Yeah,
Show
sure.
video. Okay. Okay. Yeah. So sometimes the animation shot is slow. This one is from the anim school. It's not this rig is not too complicated, but still it doesn't run at the real time. You can see here, like it's like 6 FPS, and we can generate a new Nemo rig from this one, a faster one, 10 times faster actually, and we can just switch the rig. Yeah, switch the rig reference. Yeah. It looks Yeah, these two rigs are exactly the same, so we can just replace the rig reference and the animation keeps the same. And here is, yeah, here's the comparison, like the two rigs, they are exactly the same. This one is made by riggers, by manually. This one is generated from the left one through Nemo Puppet. And this one is for animators. Animators can work so smooth with this one. Okay.
That's really nice, but that's not the only thing that can do, because one of the things that you show me this summer on Annecy, that it was like job dropping, because basically it's what you explain is like kind of like evaluation engine, something
Yeah,
that
yeah, yeah,
runs on the background,
yeah.
like a plugin or something, and then because it's external, you can basically like port that to other DCCs, right?
Yeah, yeah, yeah. It's kind of it's actually a side effect because the Nemo Puppet has been in operation for like 3 or 5 years. Yeah, uh, because our customers has started to be curious about what if it can be, because like Unreal Engine and Houdini, they are promoting their animation features.
Mm-hmm.
So people are starting to ask, what if can we use our assets in the Unreal Engine, Houdini, or Blender? Because their assets are made in Maya. And so when we are talking, I realized that okay, this is possible with the help of Nemo Puppet. This is impossible if you just started to think about these questions, because the rigging features of Unreal Engine and Maya, they are very different. It's
Yes,
impossible like you can bring a rig somehow converting it to the Unreal Engine control rig. It's
correct.
impossible. But with Nemo Puppet, we can do that because Nemo Puppet is not just a Maya plugin. Actually, it has the real computation backend. It has nothing to do with Maya. We can offer you a simple executable that can generate animation from some animation curves without any help of Maya. Maya is just an interface to animators in our perspective, because we want to keep like animators workflow intact. They have to use their same. They have to use their familiar controllers to do their work. So yeah, I'll just show you the, yeah, this is the, where I did. Wow. This is a short video, like bring the rig from the Maya to other softwares.
But not only the rig, you told me also like that the animation can be ported, so you don't need to bake animation.
Yeah,
So
yeah, yeah.
you also handle that part, right?
Yes, I will show you another video. I only have videos for Houdini because Houdini is our first. Okay, for example, if we have this, this already animated in the Maya, and we have the rig in Houdini, so we can just copy paste the animation curves. Actually, we can just export the animation curves as a JSON file, as a keyframe JSON file. You see, this is actually a play-fast process, but it doesn't need to evaluation the rig because we are just extract the animation curves from the shot. So in Houdini, we can just import the animation curves from JSON, and you don't need to do the animation again in Houdini. You can just bring it from Maya to Houdini or from Houdini to Maya.
Yeah, and I think it's but doesn't bake, doesn't sample the curve, so you still have, if you don't have one. I mean, normally when you bake like an animation of to move from one application to on the other, you need to just convert every keyframe to like every frame to single keyframe, so it's bake it, and you have this dense data that it's the one that you move, so you don't need to um, to keep the tangents of the curves and things like that. But here I mean, you are keeping everything, so you don't have this sample high density data on the keyframes, right?
Yeah. Because the controllers are exactly the same. We call it a dual rig. So it's exactly the same everywhere. So the keyframes are kept. You don't have to change that. But yeah, we have put some effort on to solving the coordinate issues. Converting the animation from the Maya to Houdini is easier because they share the same coordinates. But for Unreal Engine and Blend, it is harder. But we solved that.
Yeah, when we were working on UER, yeah, we were also like, I mean, we don't handle that basically.
It's quite complicated. Yeah.
Yes, but the thing is, you still can. I mean, it's quite new, so there is a lot of, I guess, a lot of roadmap ahead on the development to keep adding features, especially like also like this portability for other DCCs. Like right now, it's Houdini that is, for what I understand, it's the most advanced in terms of the features that you support. But you have also Control Rig and Blender, right?
Yes, Houdini is the first software we supported because most studios here are working on Maya. So Houdini is not for like animators; they are for CFX artists. Because CFX artists used to have to handle with the dynamic or geometry cache in the Houdini. They cannot. Everything is so complicated. Even if like drag the character back to the origin, it's complicated because the character may be rotating or something. Yeah. So with the help of the rig, actually, controllable rig in the Houdini, the CFX artists can be a lot easier to handle the animation for their solving process. Yeah. So so Houdini is our first supported software, but we attended the NSC this year. So at there we heard a lot about a lot of advice from the studios like could you support Unreal Engine? Could you support the Houdini? I showed the Unreal Engine demo in NSC because we have a meeting there. Yeah, so I saw you are developing UE gear, so I thought it would be cool if I can show you. Like there's Nemo Puppet that can do something about the Unreal Engine.
It's really, if you want, we can talk a little bit because there are some caveats also, like what you get in one and what you get in the other. That's I think it's interesting. And first of all, like what you did, it's amazing. I remember I went to the booth, the Epic booth, until Chase and other people there, like you should check this because it's amazing. And but there's, because you have your engine behind that, so means that I mean, the portability when you do like certain workflows, it's one-to-one. It's you were using this gear Space Marine from Emilio that you ported, and it's exactly the same curves, shapes, everything. With UE gear we have a kind of conversion that it's not the same rig, so that's obviously not good because ideally we should have what you have, that is the same rig. But on the other hand, because you use your engine, the rig, if I recall correctly, it's one big node there that have all the inputs and outputs, and that's it. So it depends. Like if you want to do linear workflow, it's amazing because you have that perfect. But for instance, one of the limitations I remember, and this is something that maybe you can add more information here, is like if you want to layer, like if you have the mockup and you want to layer on top of the or under the rig, so the rig layers on top using the backward solver, that's not possible, right? Or at this moment?
Yeah. At that time, I thought it was impossible. But when I come back to China, a lot of customers are started to test on the Unreal Engine version of Nemo Puppet because it was just a fun video, a cool video to show you. Yeah,
Yeah,
check
yeah.
out this.
It was like I did this to show you to you. Like, wow.
Yeah. But when I come back, it becomes a real stuff. Yes, we have a lot of people
Yeah, I mean,
testing on this in the past few months. So they are actually using this in their project. And of course, someone mentioned like, can we have the backward solver?
mhm.
Yeah. Yeah, they have gave some solution to that. Yeah, it is still working, but I won't say it's impossible now. I would say uh, it's complicated. The basic idea is because the Maya rig can contain multiple deformers,
Mhm,
more than just the bend shapes and skinning.
mhm.
And the backward solver kind of working on the skeleton. So that doesn't make sense because between the skeleton and the final mesh, there is still plenty of the deformer, maybe plenty there of the
Yeah,
rigs. Yeah, but the basic idea is if you are just using simple rig. For example, the skeleton is skinning and the mesh. So we can use the backward solver on that kind of rig. But if you are using some advanced deformers, the backward won't work.
that's super cool. Yeah, we had the same issues where we had to some trade-offs because yeah, like you say, it's based on the skeleton, and the skeleton sometimes don't have all the information that you need to move certain configurations of the rigs. Where when we did the U-gear, there was some assumptions like if you used the backward solve and you want to readjust or the setup construction solve, like there's some assumptions when you use these workflows that sometimes you cannot have always related to joins. For instance, we have many controls that are not related to any joint specifically because there are pivots for convenience for the characters. So to do the backward solve here, we do some assumptions. Some of them are like up to the point that we have to tell this component, okay, this is your relative joint for backward solving, because the component doesn't generate any joints, so it cannot basically revert.
That's
So
true.
it's a bit, yeah, it's more, it's not like black and white like you said. There is the
Yeah, yeah.
gray area that it's
Yeah, because sometimes the client, as a product developer, I will say, okay, that's impossible because that makes sense. But the customers, they are so urged to use that on their project, so they will come up with some ideas. Maybe that will work. So yeah, I should mention that I'm not a rigger. I didn't do any rigging. So I can sometimes I can only understand half, at most half of what you are talking about, because I know the fundamental principles, but I don't. I have never. I can never, reading a character. Yeah, it's out of
yeah.
my abilities.
That is interesting, but you're making tools and technology that is helping us as a rigger. I consider myself more a rigger than a developer. Even I develop, but yeah, it's right that the skill set sometimes. I mean, I wish I can do what you do.
Yeah,
Like, but
yeah.
yeah,
A lot of brilliant ideas come from the users. Yeah,
yeah. Always, I always say like my rigs are as good as the team with which I work, like the animators giving feedback, animation supervisors, art directors, like modelers, like everybody adds to the total. So it's very important that this teamwork, because yeah, sadly, unless for me, I can do only this part, but thanks to working with other people, you can improve
yeah,
everything. Yeah.
yeah. I think that's a fun part of the developing a product.
Um, I was about to ask a question regarding the. I would like to talk a little bit more on the technology-wise, how you do it, or how it works, because one of the questions, I was talking with some friends, and I was talking about Nemo, obviously. It's like, for instance, the you get these speeds on Maya, only talking about these speed improvements, and for my tests, yes, it's 100% real. There is some caveats that we can talk later, but the friends were asking, like, for instance, do you handle any drawing on the Maya window? Like, do you draw the OpenGL on top or DirectX or something to speed up?
We definitely use a lot of like the corner technology in the Maya. But the most important is the viewport 2 API. It makes sense because with the help of viewport 2 in Maya, we can just all the deformers are computed on the GPU, and we can just pass the CUDA buffer from the GPU to the OpenGL or DirectX to the rendering API of the Maya. So there is no like pullback from the GPU. They're just the same buffer. The computation, the computed result are just instantly used for rendering. So that's a huge part of the overall performance. Part we didn't pay. Of course, we didn't. Put a lot of effort on that because that's what implemented by Autodesk. But I would say that's the most crucial part. If we lose that, we won't be so fast. Because you have to like output like millions of polygons every frame.
I see. It's the same for the other software. So you or depending on the software, the application, you handle differently the output for.
Yeah, that's a good question. I haven't implemented any of the direct join stuff in any of other softwares because I'm not. As I realized that there is no such things in our software, but I'm not very professional, so I'm cooperating with SideFX and the Unreal Engine and the Blender to make sure to figure out if it's possible on our softwares.
Yeah, but it's really, it's really interesting because there is a lot of so for instance, like nowadays all the pipelines are on the mids and big size studios. They're using different softwares. Right now I'm working more, it's like for video games, obviously it's Maya, and the majority it's Unreal Engine. There is other that it's more for linear content, that the prevalent pipeline right now, it's Houdini and Maya. So Houdini handles the vast majority of the pipeline based on USD, and there is Maya that it's the hub for animation. Obviously Blender, it's rising star right now. It's still like a lot of caveats on the implementation on pipelines. Also like licensing, that's another thing that maybe we can skip this time, like when you develop tools and things and some studios that don't want to share stuff, like there are certain things that are part of the capabilities of the software that's no comment there, but it's I think that they have a really nice stuff. Yeah, there's all their other managerial things that are in the play here, but right now I know the USD organization, they are talking or to implement certain evaluation rigging capabilities to the USD format, but we are years ahead of having something that is what the people imagine, that is Nemo Puppet, that is you have the rig in one place and you have it in the other.
Actually, people here the user calls the Nemo Puppet
the what?
Rig USD.
It's I don't to be honest, I don't know if it compares for many reasons, because but definitely it's doing something that many people has been asking. Even that you said like it was incidental, your first goal was to speed up everything, but turns out that doing this technology allow you to do the portability also.
I know it will work at the first before the product even come out. I know it is possible. Like with Nemo Puppet, we can bring the rig from Maya to everywhere. I know that, but I don't. In the past, I don't see it as a real requirements, because most animation artists working on the, I want to say most of our customers, the commercial studios, the animation companies, they work on, their animator works on in Maya. So that then make, so I know it's possible, but I don't know it could be a business. So yeah, but I changed my mind now. So I started to develop all these migrations to other softwares.
Yeah, it's really, yeah, I think it's a future like this like portability. We for a year where we decided it's not portability but rebuildability, if it's a word that I can say it, where okay, we have this data that is general that we can reapply to build another rig similar in another DCC. That's the approach. Obviously, technology wise is much simpler because we don't develop like the base technology. We just focus more on the workflows and pipeline than technology itself. And I guess it has its advantages and disadvantages. Obviously, when we port, well, not port, but transfer or rebuild, it's native to the application, so that can have certain advantages, but also disadvantage that is not the same. You lose in a lot in the translation. In this case,
Yeah, it's
yeah.
always hard to do the translation conversion between softwares. I think the today's situation is due to the effort that these softwares, they are putting a lot of effort on animation features. That's why we are starting to develop rigging capabilities for them.
Yeah, for me, for instance, I'm starting to use more Blender and to learning, but one of the biggest concerns I have with Blender right now, it's a great software because it does everything really great, like it's well rounded in general, but if you focus only on animation, and I know they are working hard on that, but if you have like a studio with a lot of people doing only animation, they don't do the rest of the pipeline. I still feel like the speed, and I meant the playback speed when you have like a feature film quality rigs, it's not as fast as Maya right now, and obviously not as fast as if you add on top of that Nemo Puppet. So with Nemo, that it's also solved. I mean, I didn't try this on Blender.
Yeah. For the Nemo Puppet, for the Blender, if we are talking about it, the main bottleneck of the performance is due to the I/O, because we have to use the Python API to write a lot of data during every frame, because they didn't provide a C++ API.
And never will.
Deform API, even in Python.
Yes.
So we have to use a Python script that it will execute every time you change the frame or change anything, change the depth graph. Yeah, it will execute and update your mesh. So this is that's the basic idea. And with the test, it's like for a single character with like 200,000 of polygons. And the speed will be over 20 FPS. Yeah, that's the basic case. The performance is more about the final output polygons.
So the same rig in Maya, can just to put comparison, using Nemo Puppet in both applications right now, how fast will be?
It will certainly be over 100 FPS if it's not super.
Okay, so in this case, what we are talking is like, obviously we get the advantage of portability, but the speed upgrade, it's seriously bottlenecked by the API that it's based Python.
Yeah, it's still faster than original Maya rig.
It's still faster, but it's not like full power that anyone can deliver, because
I'm counting on some solution to the I/O bottleneck. Yeah, that's always the problem.
Yeah, the thing it's what I heard, it's there is no C++ API coming, so the only if you want to do something on C++ on Blender, basically you need to fork it and do like full compilation, and you can change whatever you want. That's the point of everything of it.
To be honest, that's not because of the C++ API. Python can do many things. Even the artificial intelligence is written by Python. Most AI program is written by Python. I used to work for an AI company. The performance is not a problem of the Python. For example, Maya provided something like you can directly use Python to directly manipulating the buffer in the memory. So that's faster. The problem is that we are outputting the polygons as some strings. That is a terrible idea. Yeah, but it's okay now because most assets in Blender they are they are down. They are less than 200,000 polygons. Yeah. That's a quite high standard.
I see. So yeah, it's I guess the same applies for Houdini or Control Rig in Unreal. Yeah. There's some caveats there where you get this, but how is the
Control Rig is much faster.
Yeah.
For now, I didn't get any feedbacks on the performance, and our customers for Unreal Engine, they are they are like the animation film producing companies, so their assets are quite heavy. But still, the Control Rig is working well on the performance. And for the Houdini, sometimes it will for most cases it's okay. But Houdini is software designed for visual effects, not for animation. With so many nodes, and actually they call it objects in Houdini, it becomes very laggy to manipulate the different controllers. But unfortunately, they realized it. They have the Apex APIs, especially for this. So I'm expecting if I have integrated into the Apex API, it will be solved. The performance is not a problem. But still, all these softwares, the speed cannot be compared with the Maya, because our Maya plugin has the theoretically the fastest transfer speed, because there is no transfer at all. It's just the GPU buffer is just directly used for rendering, so there is no I/O.
That's very interesting. It's and at the same time, it's I guess not surprising, because I'm still like I know, like, I mean, you just need to open any I would say social network, and the people is always complaining. Sometimes Maya crash, Maya this, Maya the other. But at the end of the day, it's the for animation still the king and still rocking strong.
Yeah, it has a very solid fundament, I would say.
Yeah, it's very interesting to hear that the limitations, and also, but it's still like amazing that you can, even with this bottlenecking or with these limitations, you still can do the rig once and have it in different DCCs. That's amazing, because like not only for animators, but also like you said, like another conversation we had, like for character effects artists, for instance, instead of having Beckett, having the rig live, it opens a lot of possibilities. And also like studios that may have mixed pipelines, or even studios that doesn't have the same pipeline, like let's say a studio that animates in Maya and another studio that use Blender. If they want to share a production and share the same assets, they can do it. They don't need to rebuild everything from scratch, and the gain's still there for Blender in terms of performance, even it's not as big as Maya.
I don't know if you read the survey like Blender Foundation did this year earlier. They are asking their users how many of their users are making money with Blender.
I didn't see.
More portion, like I don't know the real number, but it's a small portion of users are, as you can imagine. Yeah, but
They have
with
big
Nemo,
beta.
we can the animation studios can outsourcing the animation shot to the Blender users, even if they have to work on the maybe Maya pipeline. But also for now, they can outsourcing their shot to those amazing Blender animators. Yeah.
Okay, let's change. I want to talk a little bit how Nemo Puppet works. Can you explain? I know the function like plugins and generate this data and send it and blah blah blah. But can you explain it a little bit how it works in terms of like if I want to put today my rig to test it, what I need to do it? How I can test my rig in Nemo Puppet?
Oh, I think it would be best if I just show a video.
Okay.
This one, I make quick start videos. Here is a tutorial showing how to make the rig, a Nemo rig in Maya. And first of all, yeah, it's 3 minutes, so I will speed it up a little. Just opens the Nemo export tool and select a place to put the exported content. So this process will separate the asset into two parts. One is for the confidential data, and one is for the information. That the information is about the control logic of the rig, and this graph JSON will be uploaded to our website, so we can do some acceleration on that. And this graph only contains some rig control logic data and nothing of the sensitive information. And we will do the data masking on that. We will turn every names of the original file to anonymous. Also, it's perfectly safe, but if you don't believe me, you can check the content of what you are going to upload. Okay. After we're logged in, just drag the graph JSON.
So basically, just upload one JSON file. That's it, right?
Yeah.
And you can, I mean, you can read it. What is there?
Yeah, we can read the evaluation logic from this graph JSON, and we can we can compile it actually into a binary file. And then we can assemble the binary file and the original confidential data of the original rig, combine them together and create a new rig, a new Maya file. Yeah. And this new Maya file can be shared with animators. They just need to have Nemo plugin installed, and they can directly open it.
That's it. Super straightforward.
And it becomes faster. And to animators, they don't care. They just enjoy.
Yeah, exactly. This is something that even, I mean, the animators will not do that. It's probably the rigger or some technical artist that will process all the data and just give it to the animators.
Sorry, I understand your idea. Like this workflow is designed for the riggers or TDs, but the animators are so excited about it, and so they are doing it themselves. So we have a simpler version, like the one click. You just drag the Maya file in. You don't want to do anything. You just drag the Maya file in and wait for a cup of coffee, and the Nemo rig will come out. Yeah, I do it all day.
And yeah, I think maybe it's a good moment also to comment like a couple of things. One is that we are partnering to improve better MGear and Nemo Puppet to work together nicely, and that's a partnership that we've been talking and organizing for some time now. And also, while we will release this episode, we will add some promotion codes, so you can grab that code and use it to test it, right?
Yes. Yes, because we are trying to make the Nemo rig like exactly the same as the original one. And sometimes we may miss something because we are developers. We are not. Sometimes we miss something. So I think it would be best if for example, mGear can provide some kind of test, or we can do it together. We can work together to make sure the Nemo rig has kept every features that original
Yes.
mGear rig provided, and also for the other softwares. For example, there is no rotate pivot in Blender, so sometimes that would be a question.
Yeah, I don't know that.
Or for example, the gyro controller depends on the rotate pivot, and that would be a problem. We cannot solve that by ourselves. It would be best if we can work together with the riggers, the rigging system developers together to make sure we can develop some rig that can be available and also 100 accurate on every softwares. And yeah, and also for the promo code, just when you register the account on the nemopuppet.com, you can type in the mgear in
Yeah,
the
I'm gonna post it somewhere on the video description here. Don't worry. Yeah, we'll post all the information with the links. So yeah,
you will get 3 months free trial.
yeah, but basically like what you were describing is what we are doing. I'm basically testing some of my rigs and asking, oh, this doesn't work, and you told me, oh, you need to do this, or oh, I didn't thought on that, and let's adjust this, or so we are trying to make it like, I mean, the basic, it's like without changing any of our technologies, but ensure that they talk nicely together, and all like the features that you have in mGear. Like for instance, one of the things that we were talking like a few weeks ago was the custom peak walk on mGear that I did some tests and I didn't see this going through, but you told me quickly like, oh, you need to do this to keep part of the graph, so you don't need to lose this if you do this. So this kind of thing. So the idea is that eventually this next weeks or after this video, I will try to document properly how you need to convert mGear rigs to the detail, like, because there are options, right? When you do the conversion, you have optimizations levels. Also, there's some trade-offs, no, in precision. I remember we were talking about like you have like floats or double precision kind of in certain elements. So that obviously it's something that you need to configure to balance your speeds, right, with certain kind of precision on the results.
Yes, because the different rigging system may choose different units. So sometimes they may require double precision. Sometimes float precision is enough. The float or double will affect the GPU performance, but that's okay. You can either float or double is okay, because the performance in Maya is out of the animator's needs. It's 100 FPS now, so it doesn't matter actually. So yeah.
And 100 for my test, I got 100 with several rigs. I mean, it's not one rig 100; it's several assets, and it can go up to 100 FPS easily.
Yeah.
So it's not like one single. So if you put several, still performing. I'm doing my test on a laptop. It's a really nice laptop, by the way. Shout out to Lenovo for providing this amazing laptop. But yeah, it's still a laptop, and yeah, it's really fast.
Yeah. Also, we support the animation, the evaluation catch of the Maya feature, and we also support that. And you can use both the Nemo Puppet and the evaluation catch if you have like tons of character at the same shot.
I'm very excited on this collaboration, to be honest. I'm like, we were talking last couple of weeks, like almost daily basis. We are all in on that. Maybe just to finish, the last topic will be what it's the future for Nemo Puppet. What do you want to talk a little bit? What is your goals or your immediate goals, and what do you want to do in the future?
The future for Nemo Puppet is not too much information, because my part for Nemo Puppet is kind of enough because I'm receiving less and less feedbacks on the my rigs, and there's still some questions. For example, like if my asset is using like hardware shaders, would that be possible? Yeah, we provide a version for the hardware shaders, but that would be kind of slow and not super fast. But people always want to be the 100%. So yeah, there is still some kind of issues remain, but I would say that's the Maya part was like close to the end of story, and the future of Nemo Puppet we will focus on the extending the Nemo Puppet to other softwares. This is actually very hard because I would say all each software is a brand new world. They have a different philosophy. So it's easy to bring this bring Puppet into the software because we just plug in and it works. Yeah, it's maybe 1 week or 2 weeks of work. But if we want to be like this rig can meet everyone's needs in that software, it would be a hard work and it will require a lot of cooperation with the studios, with the software developer teams, and so on. Yeah, that will be the future, I would say, of Nemo Puppet.
Amazing. Well, Ivan, thank you so much for your time and all the nice explanations. And well, I guess see you around maybe soon here in Tokyo, I think.
Okay.
And
I'm excited about that.